Hello once again, our most valued student. My name is Confident and welcome to the ultimate guide for mathematics grade 10. And as I said, we're looking at analytical geometry, and we've already done the first part of this lesson where we're looking at the distance formula. So if you missed out on lesson number 1, I will encourage you go and see how we discuss this distance formula. So we did the first questions and some examples here, and then we were looking at the next example on the distance formula. Look at this one. If you are continuing, it means you are following up, and I'm saying congratulations to following up, because this is again the most important part of the distance formula. You'll see when you are needed to find x here. It says given the points P is that, Q is that, and R is that. It says determine the values of x if P is equidistant from Q and R. So again, as I say, the sketch is not really necessary, but I'm trying to make it make sense to you. So if I can draw my Cartesian plane like this and say, okay, you are given, just to have an idea what it means, I've got my y, I've got my x. P means is equidistance. It means it's at the center. That's simple. What the symbol means. Equidistance. Given the points that, determine the values of x if P is equidistant. So what is at the center is P. That's what it means. Now Q is 2, 7. We can come here and say, okay, I've got my Q somewhere there. This is just a rough estimate. Let's say this is my Q, which is 2, 7. But now look at R. They are saying R is minus 10. It's difficult to know where the other value is. So it's minus 10, so I can draw it. This is the negative, so it can be here on two sides, which is positive, positive. That can be my R, and is minus 10x. So by the way, if you remember the quadrants, this is quadrant number 1, but you do that in especially when you deal with what you call this trigonometry. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So you can have Q in that, or I can have it in this one. If I can draw it, it can even be here. Q doesn't change, but R can be maybe in this quadrant. That's quadrant number 3. So you see that we've got two different points, possibilities of R, which is what is still negative 10 and x, but here look at this, here it will be negative, there it will be positive. So the question is which one is which, but what we know is P, our P guy, is at the center of all this. So if I come and say where is our P, it says that P is minus 2, 3, somewhere here. I can have my P, alright, as what? P is minus 3 and 2, so it's positive. Or I can make P be here. It's still the same. Remember, it's not drawn to scale. Minus 3 and 2. That's my P. But don't forget, P is the center, the midpoint. So what you do the same thing we did when we're looking at this part of being equidistance. Remember, this was R, and we said what is the condition for equidistance? It means the distance from R to P is equal to the distance from P to Q. That's what it means. So when you can write that, it will then start making sense. Let me take this off for now. Okay, so I just don't want that. It was from the previous lesson. So let's look at this now. We are saying when you're looking at being equidistant here, we are saying the distance RP is equal to PQ. Let me write that down. RP is equal to PQ. What is this condition? It's the condition for equidistance. Right. So P being in the center. Are you with me? So now what it means, we need to find that distance RP. So the distance of RP, what is it? You use the formula to say it is X. It doesn't matter, you can say XP minus XR, but you square it, plus YP minus YR. And then what you do, you square it. Then you need to bring those coordinates now to say what is the coordinates of R, of P, and then of Q. Let's bring the coordinates in. So what is the coordinate of R? The coordinates of R was minus 10x. Alright. And then what's the coordinates of P? The coordinates of P was minus 3, 2. And then what's the coordinates of Q? The coordinates of Q was 2, 7. Alright. So this is what you need to find some simple information here. So with this, we can find now the distance. It becomes square root of, now bracket XP. Remember, I said it's easier now. This becomes your X for P, your Y, your X is your YP. And then the next one becomes R. This is your X, R, Y, R. And the other one is what? Q, XQ here, and your YQ. Just that. And then you put in the values now. What is XP? You can see it's minus 3. Then minus XR. You see, negative and negative 10. Remember that. Don't forget that. Plus YP, it's 2. Minus YR is X. So maintain that X as is. Leave it like that. And then, but now, you see, I can't use a calculator throughout. I can't put a square root on my calculator. If I take my calculator, I can't now do this because of that X. It's not possible for me now to say square root of, then I put a bracket, and then I say minus 3 minus 10 squared, and then after that I'll say plus, and then I'll say 2 minus what? You see, I don't know the value of X, so I just need to simplify what is inside here. So I'll simplify this one, minus 3 minus 10 and squared. I just have to simplify that for now alone. Equal to, do you see that it gives me a 49? So for now, I maintain my square root. I will have 49 plus 2 minus X squared. Right. But now I need to remind you, what is this? What is this? Let me just do it here. What is this thing? 2 minus X squared. You need to simplify that. You must remember it twice. That's what it means. It means 2 minus X and 2 minus X. Don't be tempted to say this will become 2 squared minus X squared. No. You need to expand the way you expand. How do you expand? This multiplies that, this multiplies that, and that multiplies that, and that. You remember the FOIL method, which is 2 times 2 is 4, 2 times minus X is minus 2X, minus X times 2 is minus 2X. These usually add up, and then negative X is plus X squared. You see that? Then it's 4. If you add this, minus 2 is common. It's minus 4x. Use a calculator. Minus 2, it's minus 4 plus x squared. Alright. This is what we put in here, so that it goes on to say equal to square root of 49 minus, now it is 49 plus, then we've got 4 minus 4x plus x squared. See, so now we have got common terms. 49 plus 4, what is it? It's what? It's 53. So you've got 53 minus 4x plus x squared. See, it's good marks. In an exam you might find that this is 5 marks, the whole question. So we have done RP. So now we want the distance of what? The distance of PQ. Let's do that now. I can do it maybe here to say distance of PQ is equal to square root of, then we divide. Remember how it's like, it's xp minus xr squared plus yp minus yr squared. Alright, which is equal to square root of, now xp, we come here to say xp, it's what? It's minus 3, so it's xp minus xr. Distance of pr now, pr, okay. What did I find? rp, so this is the same thing. I think pr and rp is the same. Actually I want pq, I don't know why I'm doing the same thing here. I want the distance of pq, so here it must be q here. Where there is r, it must be pq, because rp and pr is the same thing. So I need a q there, a q. So it's xp minus xq. So what is xp? It's minus 3 minus xq minus 2. So minus 3 and 2. So it's minus 3 minus 2 what? Squared plus yp, not q, yp minus yq. Yp is 2, yq is 7. So it's 2 minus 7, and then what? You square. Now since this one doesn't have x, you know what we do? We just find the answer now. As a whole, there is no x. That's why you put a square root, and then you're going to say negative 3 negative 2 squared plus what? 2 minus 7 what? Squared, equal to 5 square root 2. So this is 5 square root 2. So that's units. So alright, we got this, and then we come to the conclusion. rp is equal to rq. So you look at this and say, okay, it says rp, meaning distance of rp is equal to distance of rq. Guess what? I have the distance of rp, which is this. So I'm going to write square root of, okay, I can drag this here. Let me drag this in the center like this. So the rp is 53 minus 4x plus x squared is equal to rq, which is this. Remember, that's rp, what did I write? Rp is equal to pq. Why am I doing this? Rp is equal to pq. That's what we talked of, the equidistance. Rp is equal to pq. So let me write there pq. Are you with me? So what was the distance pq? 5 square root of 2. Now what do you do from here? I know it looks long, but it's very important. What do you do from here? From here, to get rid of that square root, remember, to get rid of a square root, you square. But what you do on the left, you do on the right, you square. That's what it means. That's how that square root falls. So you'll have now 53 minus 4x plus x squared is equal to, then you have to simplify now the 5, this 5 square root of 2 squared. Not inside. If you do this, it will give you an error, you see. So be careful how you do that. Let me remove. You play forward like that, then the square must be outside. You see that? Then it gave me 50. Be careful there. Then from there, I need to simplify now this. This is a quadratic equation. And how is a quadratic equation like? Remember, it says quadratic equation ax squared plus bx plus c equal to 0. So that's how you must arrange it. So you start with the x squared. So you'll have x squared, then minus 4x. Then I've got 53, which is plus 53. And then I take this to the other side. It will be minus. Remember, it's positive. So it will be minus 50. Because you jump the equal sign. Remember, equal to 0 now. Then you simplify it as x squared minus 4x. Now 50 minus 53 is plus 3. is equal to 0. Now you've got two things, two options here: quadratic equation or the quadratic equation. How do you want to solve it? You can do the normal solving, where some of you are good. You simply do this. You still remember how you solve it. Then say equal to 0, whereby you're saying I've got x here, I've got x here. I'm looking for the factors of 3, which is 1 and 3. And then I need to add them to get -4. So it will be like this: x minus 1, x minus 4. Then you're going to say x minus 1 equal to 0, or x minus 3. If they taught you well on this one, you won't have a problem. But check my previous lessons, I cover this product sum. So this goes there, x is 1, or this goes there, x is equal to 3. But I will say, because I'm interested in using the quadratic equation, the quadratic formula, sorry, let's use the quadratic formula here, because it's very important that you master it also. So let me write down the quadratic formula. It says what? Remember, from ax squared plus bx plus c equal to 0, and this is the formula. It says x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. I'm saying that. So now you can see, now how do I find my a? Look at this. I have here x squared, means there is a hidden 1. So if I cut here on the x squared, you can see that a is equal to 1. What about b? The coefficient of x is b. So here with the negative and the signs, so you can see that b is equal to what? -4. What about c? Take the signs together, and c is equal to what? 3. Then you apply that in the quadratic formula. It must give us the same answer, which is x is equal to minus my b, you put a bracket, you say -4, because there is the minus of b and there is the minus of, there is the minus of the formula and there is the minus of b, and then say plus or minus square root of bracket b squared. Always put a bracket. It's -4 squared minus 4a is, put a bracket, is 1, c is 3. I'm just reminding you, these are very important things. Over 2, my a is a 1. Now your line here, it must overlap. When you're doing a division line, don't just leave it there. For example, you do like this, they will penalize you. Your division line must come all the way like that. That's the proper division line. Alright, so let me just take off this one. Do you see that? Of course, it mustn't go beyond the equal sign. Then from here, you apply your formula, and then you will get two answers. So let's do that. It's a fraction first, and then you're saying minus bracket -4, start with a positive 1, plus square root of, please there must be a sign there, don't leave it blank, and then bracket -4 squared. You need to know this formula, because there are questions that will force you to use this formula. Minus 4, a it's 1, c is 3, and then all over 2a it's 1. Right, then when you do that, equal to, see, x is equal to 3, we just got it, and then you play back, then minus x is 3 equal to, and x is equal to 1. You see, it gives us the answer straight away here. X is equal to 3, or x is equal to 1. Are you with me? So that's the answer that we got in here. Now we come back to the question. The question was, it is given that determine the values. Oh, there it is, the values. So it's not 1, it's more than 1. Remember, I told you to say that the values of x, it can be, in this case, those are the values the values of y, which means they are saying the y value there. I know we're talking about x, but it's actually the y value. So the values of x is 3 and 1. So you expect, when you're drawing it, it's actually in the first quadrant, all of them. I thought 1 would be in the other quadrant. So you're saying x can be 1 here, or they're saying x, where is that? that value of x, remember the y. The other one, they're saying it can be a little bit on top, which is 3. It can be actually somewhere there, like this. You see what they're saying? Minus 10, they're saying there can be another point here, which is minus 10 and 3. Because this one is minus 10 and 1. So that is that. They are values of x. So guys, that's how you come up across these questions. You solve them. Alright. My time is up on one question, but I want to still do this one. It says example C. Example C is a point 1 minus 2. The point D lies in the second quadrant. Okay, they are telling us about the quadrant now, and there's coordinates this. If the length of CD is this, determine the value now. See, they didn't say values. Now they want the value of x. Are you seeing that? So what do? They're saying C is the point that the point D lies in the what? Second quadrant. So now I'm not going to, okay, let me just remind you of the second quadrant issue. So I told you that when you're drawing like this is your Cartesian plane. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So they're saying whatever you are having, that particular point will lie in this quadrant, and then they want you to find that point. So let's put this together. What is the coordinate of C? C is what? 1 minus 2. And the point D lies in the second quadrant, and there's coordinates this. Let's do point D. What are the coordinates of point D? It's x and 5. Are you following up? And then they're saying if the length of CD is 53 units, so distance, the length means distance of CD is square root of 53 units. You see that now? And then what's the question? Determine the value of x. You see, they like this question also. They like that. So what they've done here, they went ahead and calculated the distance. So they've got the answer already, the distance of CD. But you're like, okay, since we're dealing with distance, is the distance formula. What is the distance of CD? You calculate like you didn't know about it. Just calculate CD. So what you're gonna have, it's xd minus xc. You see, I'm calculating squared, plus yd minus yc squared. Pretend you are not aware of this. You are only interested in finding the distance CD, but it will be in terms of x. Look at it, square root of xd. So you come here and say, this is my xd, this is my yd, this is my xc, my yc. So xd will be x minus xc. Look, it will be 1 there, right? Then what you do, you square, plus yd is what? 5 minus yc. Say minus 2 squared. Are you seeing that? Similar things that we did previously. Then you simplify. I told you whenever there is an x inside, I can't use a calculator here. Then it will remain here as what? As x minus 1 squared. Plus, but I can simplify the one which is 5 minus 2 squared. I can simplify it using what? Using the calculator, which is bracket 5 minus 2 squared. It's 49. Okay, it looks similar with the previous one. Okay, but now I need to remind you again, what is this x minus 1 squared? It's what? It's equal to, you write 2 brackets, which is x minus 1, x minus 1. Then you open this bracket. X times x, it's x squared. X times minus 1 is minus x or minus 1x. So it's this, that's why I got minus x, and then it's this, which is minus 1 times x, again is minus 1x or minus x, and then it's that. Minus 1 times minus 1, it's plus 1. When you simplify it, it will be equal to x squared. Remember, I said there is a 1 here and a 1. So minus 1 is minus 2x plus 1. Guys, you need to know how to perform that. That's what I'm going to put here. To say equal to square root of what? X squared minus 2x plus 1 plus 49. So this one is what I did there. Are you with me? But you don't need to put the bracket in here because you are adding. So equal to square root of, collect like terms there, which is x squared minus 2x. And then what is 1 plus 49? It's plus 50. Then this is a distance. What is this distance? Is distance, as you can see, CD. As we said, that's the distance CD. But the good thing is they told us the distance CD here. They say the length of CD is 53 units. So guess what? I've got the distance CD in terms of x, and I've got the actual length. So which means I can equate these two to say I've got this square root. That's how they want you to do it. X squared minus 2x plus 50. This one must be equal to the square root of 53. You see why? Because that is the distance in terms of x, but I know the whole thing must be equal to 53 again because they went on to calculate. And then at this stage, that's where now you simplify your algebra, you square both sides. Remember, I told you what you do on the left, you do on the right. That's how that square root falls on both sides. So you'll have x squared minus 2x plus 50 is equal to 53. What is 53? Is positive. It must join the other 50, which is x squared minus 2x. Now 50 minus 53, it is plus 50 minus 53. Then you get 0. Then you continue to have x squared minus 2x here minus 3 equal to 0. You see that? Then at this stage, it's similar to what we did in the other one, where it's a little bit different though, because it's, if you know how to use the quadratic equation, remember here I told you it will be 1, then you've got ax squared plus bx plus c equal to 0. Or you are the person to say I can factorize this easier, to say I've got my x, I've got my x, the product of 3 is 1 and 3, and then when I add, I must get minus 2. So this is negative, that is positive. So x plus 1 equal to 0, or x minus 3 equal to 0. So here, take this to the other side. You've got x is equal to minus 1, or x is equal to negative 3 become what? Positive 3. You've got these two answers. You can use that quadratic formula, as we said, to say x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a, right? And then look at it. There is my a equal to 1. There is my b, I cut there on the coefficient of x. What is b? B is equal to what? Negative 2. And then there is my c. What is my c? C is equal to minus 3. I think that. I'm doing it. It might not be in your syllabus yet, but well, I have done it. So what? It might not be in your syllabus. This might be in your syllabus if you're doing grade 10. Alright, but well, we've done it. So go along with it, okay? So it's minus. Now this is minus for the formula, but b is also negative bracket, no, minus 2, you see, plus or minus square root of b squared is negative 2 squared minus 4a is 1, c is negative 3. You put it carefully so, and then this is all over. Start from there nicely with the ruler, and then you say 2, and what is your a? A is our 1. Put brackets in between. Then it will give you the two values of x straight away. You just have to be sensitive with the calculator. The moment you take a calculator, it's fraction, guys. You say fraction. Then put brackets where there are brackets, just like I indicated here. It's minus bracket minus 2. Close it. Then take the first one. Don't leave it blank in the center there. Plus square root of bracket Negative 2 squared minus 4a is 1, c is negative 3. You see that? All over 2a is 1. Then you get 1. X is equal to 3. See, it matches. Then you play back. You delete, put the minus. So x is 3 and x is equal to minus 1. You see that? X is equal to 3 or x is equal to negative 1. Then we come and answer the question. What was the question saying? The question said the point D lies in the second quadrant. Second quadrant. So you ask yourself, in the second quadrant, I've got two values of x. X was equal to what? X is equal to minus 1 and 3. Let's write those values. X is equal to minus 1 or x is equal to 3. Now they never said values, they said value of x, which must be in the second quadrant. You ask yourself, remember, these are my x-axis. So x, this direction is positive, but this direction is negative. So you can see that we cannot take this one because x is positive. So our answer here, you can say, therefore the coordinates of D are what? There it is. Minus 1, that's the x value. Take the minus 1 and 5. Because that's what they wanted. We cannot say D can be 3 and 5. No. It can't be because it's not in the what? 3 and 5 is in the first quadrant because all are positive. But D must be x negative, y positive. This is positive. It can only be in the second quadrant, as you can see. Alright, so that's the answer there. So the value of x is equal to negative 1. Guys, my time does not allow me. In the next lesson, where I'm going to do is the midpoint of a line. So we're going to look at the midpoint, and then if time allows, we are also going to look at the gradient of a line. That's how we're going to wrap it up. Alright, so join me in the next lesson. We've come to the end of our lesson. Guys, if you are not subscribed, this is the highest opportunity that you can get for you to subscribe so that you don't lose any lesson. So be our member, subscribe right now, and every time there's a new video, you will be notified. We have come to the end of our lesson. Thank you.